or turning effect of force. And in our previous lesson, we were able to define moment of force, moment over force. And we said that when we talk of moment over force, it simply refers to the turning effect of a force. We were also able to give some examples of activities where force produces a turning effect. And lastly, we were also able to look at another definition for moment over force, and this is now where we are going to continue from in our lesson today. So we are continuing with moment over force. And in our lesson, we are going to calculate moment. Now that we have already defined moment over force, we'll now go into calculations. So by the end of this lesson, you should be in a position to calculate moment in a given question. And number two, we are also going to look at principle of moment. And in this, we are going to state the principle of moments, and therefore by the end of the lesson again, you should be in a position to state the principle of moments. Now, moment over force. We defined moment over force, and we defined moment over force as the product of force So we defined moment over force as the product of force and the perpendicular distance from the point of support to the line of action. And therefore, we were able to write the formula for moment as force multiplied by distance. And we said that force should be newtons, distance in meters, and therefore the SI unit for moment is Newton meter. So we want to do some examples. We want to do some examples on calculation of moment. So examples, we can look at 3 examples. So you are told, find So we are told find the moment of the force about point O. These are point O in the following figures. So we start with the first figure here. A, we have the following. So we have this figure here. This is point O. And on this point here we have a force. And the force is equal to 10 newtons. Then we've also been given this distance. So we have been given this distance as 10 centimeters. So that is the question. So we want to find moment of the force about point O in this figure. So as we can see, at this point O, and we are told that this is the pivot. So this is our fixed point, point O, and we have a force here. You can see that the force is perpendicular. From the point of support to the line of action, we have perpendicular. These are perpendicular distance from here up to here.